Hi, I'm Todd Gardner from CertKit. We just released the CertKit Agent, and I wanted to show you how it works on Linux systems. CertKit already is an awesome way to manage your certificate automation. It acts as a central ACME client, automatically requesting and renewing all your certificates. The agent makes provisioning those certificates super easy by automatically putting the certificates exactly where they need to go and recycling the services required. This works great for private systems in your intranet or web farm situations or vendor appliances. Let me show you how it works. Here's the CertKit UI when you first sign up. First, we're going to create a certificate. The certificate we're going to create is for this Linux system, hosted at demo.certkit.dev. It's a Ubuntu Linux system running a pretty stock Nginx deployment that really just has a self-signed certificate in it right now, and we're going to put a real live certificate in it. So first, we need to create that certificate. To create a certificate in CertKit, we just go through this form. You can create both wildcard or single name certificates, and we even support multi-SAN, so you can create more complicated certificate scenarios. For our example, we're just going to create a single name for demo.certkit.dev. We support both elliptic curve and older RSA algorithms, and we're using Let's Encrypt Under the Covers as our issuer. Let's go ahead and create this certificate. To get a certificate, we have to validate that we are who we say we are, and this is done through the ACME protocol. Now, if you run this stuff on your own systems, that means you need to either open up port 80 so that you can do an HTTP validation, or have DNS keys hanging around, which is kind of scary. CertKit approaches the problem differently, and rather than your systems needing to speak ACME at all, you just delegate that authority to us. You delegate that authority by pointing a single CNAME record from your domain at us. This is going to authorize us that whenever we need to validate ownership of demo.certkit.dev, the authority for that will be passed over to CertKit to do it. Now, this is one-time setup. This does not need to change every renewal, so you don't have to worry about, messing with this every 47 days. I'm going to go ahead and make this change. This domain is registered in Namecheap. Here's their management UI. So I'm just going to create a CNAME record for _acme-challenge.demo. And we're going to point the target at this unique key. And we'll set the time to live at 1 minute so that hopefully this goes super fast. Now, CertKit is going to automatically start looking, checking the global DNS to make sure that these keys are pointing at the right place, so that when we go to try and issue the certificate, everything is going to pass successfully. Now, this could take a couple of minutes because it's DNS. As soon as that DNS thing links up, we'll automatically request and validate that certificate. Hopefully, it should only take a moment. Great, we are holding it and we will keep it renewed indefinitely. But we need to get that certificate down into the servers that need them. So the easiest way to do that is using our new agent. Under the Agents tab, we can create a new agent for Linux, Windows, and Docker. The Linux agent is installed by just copying and pasting this snippet. Now, I already have a root shell open to the Linux Nginx server, so I'm just going to paste that in and execute it. Now, when this happens, that agent is downloading the binary and setting up a service. And then that agent is negotiating a new private key authentication with CertKit. Once that's done, the agent is automatically registered in the UI. Now, it doesn't know anything. It can't do anything. It needs to be authorized in the UI before it gets any information about your certificates or your ecosystem. So here we're going to go into this new agent that I just installed, and we're going to authorize it. One of the coolest things the agent does is discover the software that's already on the system. In this case, it discovered that we have an Nginx server listening on all domains, and it holds certificates at these paths. We can use this to automatically provision our new certificate to this system. Provisioning a certificate is just the simple form. We select the certificate that we want to deploy, in this case, the demo.certkit.dev we just created, and then what format we need the certificate in. Now, we auto-detected this as part of Nginx, but if you're setting this up by hand, we support all these different formats of how the certificate could be placed. You specify where you want the certificate files, the PEM, the chains, the private keys to be placed. And we even support advanced options if you need to set the username or group that owns the files or the file permissions on disk. And then the command that needs to be run in order to reload Nginx or restart the service or whatever needs to happen once the certificates have been changed. Now we've defined this configuration based on what we auto-discovered. And once we save it, this configuration is going to be pushed down to the agent. The agents check in with us every 30 seconds to see if there's new configuration, new certificates, or anything else. That allows us to make sure that both the agents are alive and they stay as up to date as possible. With this turned green, the certificate was deployed successfully and the service was rotated. Let's check to make sure. So here we had the privacy error from our old certificate. And if we reload this, we now see a direct call to CertKit Agent demo, and we can check the certificate and make sure this is indeed a valid Let's Encrypt certificate. CertKit wants to make sure that everything is working the entire way through. So we included monitoring as a core part of our product. We're going to monitor this new demo.certkit.dev, and we detect that, hey, there's a certificate that we already have for this domain. So we're going to link it directly to that. When we set up this monitoring, we're going to periodically check that domain and check a few things. Both that certificate is valid and that the root cert is trusted, but also that the thumbprint of that certificate is exactly the certificate that we expect it to be. Now, this is super important because there's a lot that can go wrong in certificate automation. Services might get hung, a certificate might not renew on time, lots of things can happen. With certificate monitoring, we can make sure that, like, if a service doesn't refresh, you know about it days before the certificate actually expires, so that you have time to respond and fix issues before your users encounter an expired certificate. That's how certificate automation works with CertKit. We created a certificate, deployed it to a Linux system, and set up monitoring in just a few minutes. It was super easy. We just kind of walked through it real quick. This doesn't have to be hard, and you can do it for your infrastructure too. Sign up for a free account at certkit.io.